Welcome back to Area Diesel Service. Today we're going to do some collaborative content with fellow YouTube creator Dirt Perfect. So if you've been watching Mike's channel, you've seen that he's had some issues with his Volvo 140 excavator. This is a 2016 Volvo EC140EL. It's got a 4-cylinder, 4-liter Deutz engine, rated at about 120 horsepower. The issue that Mike's having is that when this machine gets fully warmed up, he gets a code for a low fuel rail pressure. So they've checked everything else out on the machine, and they've sent us the injectors so we can have a test on them and see what's going on. So today we are in the clean room facility at Area Diesel Service, thus the lab coats. This is a specialty built facility. It is a pressurized chamber. It's got HEPA filtration, special light fixtures, special materials on the wall, floor coating, a variety of different things to make this a clean environment for handling these extremely precise components. While we're down here, we're going to do a little walkthrough and show you some of the equipment capabilities. Most of the stuff we've brought to YouTube so far has been vintage, mechanical, older stuff. This is a little bit more modern facility, modern equipment, modern capabilities. So again, this is a pressurized HEPA filtration clean room facility. So this was built and constructed to the Bosch certification specification level. So everything in here has to be done in accordance to retaining a Bosch authorization, from floor coatings to light fixtures. Everything is engineered and designed with cleanliness and sanitary in mind. So we're just walking in. This is the first bay of the clean room, kind of staging, initial inspection, write-up, and just general flat surfaces. So we bring stuff in, set it up here, get the boxes opened up, take a look, develop a game plan. This is the build-up area. So this is a DX common rail solution. It's an all-inclusive common rail manufacturing and assembly workbench. It's got a computer that walks you through the different processes. It steps you right through setup of these injectors. Extremely precise measuring equipment, talking to the computer, appropriate fixtures, everything you need once you're cleaned up to go back together. So that is the DX solution. We also have the Bosch build-up station as well, and same thing goes on there. So you've got a computer, put in your part number, it tells you what goes in first, what's the specification, set it, measure it, click yes, takes you on to the next step. So Bosch on one side, KD on the other. Alright, so this is a Bosch EPS 815 with the common rail solution set up on it. So this is the required machine if you're running under a Bosch factory authorization to rebuild and repair Bosch common rail fuel injectors. Test stand, like many others that we've had forever, now computer controlled. If you look inside the test area, you can see that the bench is effectively turning a CP3 pump. So the CP3 pump is chucked up in it. That's what we're using to supply the high pressure fuel to the injectors. So this machine can run 4 injectors at a time, and it is the latest and greatest equipment for testing and repairing Bosch injectors. This is our DX common rail test bench. Similar concept as the Bosch, but from a aftermarket test equipment manufacturer. So same concept, test bench as we've always known it, driving a common rail pump that's feeding high pressure fuel to these 4 test stations. So you mount 4 injectors in it, turn the machine on, turn the pump, high pressure fuel to the injectors, actuated by this control panel, measured through the totem pole in the back, and this is just a different way of testing common rail injectors. So this machine is capable of electromagnetic, so coil style injectors, and also piezo. 4 at a time. Bosch EPS 205, so benchtop style common rail injector tester. We use this machine to run injectors that have been out in the wild because we're not certain of their quality, or if they've had contaminants, debris, that type of stuff. So we do not want to run injectors from the field in the Bosch or in the DX test machine. So these are only for injectors that have been completely disassembled, cleaned, rebuilt, and we can confirm that there's no contaminants in those injectors. This machine is designed for testing those injectors that have again been out in the wild. So you still get an absolutely high quality, perfect test. It runs through the same type of parameters that these machines do. Pilot injection, light load, full load, return fuel, has all those capabilities, but we just don't want to run an injector from the field in these machines. So 205. All right, cam box. So electronic unit injectors. So solenoid controlled unit injector, meaning that it is one unit. It's got the pumping element and the delivery nozzle in a unit style system. Electronic because it's solenoid controlled. Call this a cam box. So we chuck the injector in here as such. This machine turns the cam box, actuates this plunger, operates on the pumping element of the test equipment. So electronic unit injector, Cat, Cummins, Detroit are your common applications. Before the big engines went common rail, this is the type of injector you would see in them. Last step, packaging. So we've got everything rebuilt, calibrated, tested. We've confirmed that we have a quality repair for our customer. Last thing we do, package them up, get them shipped out. So hot seal everything here, tag and identify, sticker and label, put them in a box, we'll get them out the door. Okay, these are Bosch CRIN 2 common rail diesel fuel injectors. We are Bosch authorized. You can see our equipment here. We're going to walk you through the complete process of what we do in this scenario for a test and advise. Today we're going to feature Brandon, who is our resident expert common rail fuel injector technician. We're going to do some preliminary checks on the solenoid to make sure electrically this thing is up to par, and then we'll take it into the test room, we'll chuck it up in a machine, walk it through the process, and we'll bring you along and show you what we're doing.
Hello, my name is Brandon. I build and test common rail injectors here at Area Diesel. Today we got a set of 0445 120 424 injectors, and I'm going to start off with testing the solenoid. What I do with my Megger tester is I make sure I zero the leads to compensate the resistance of the cables. So the difference is 46, I want to zero that out. Now we'll get a true reading from the injector. So the first test I'll do is insulation voltage test. This test will tell me if there is a short from the pin to the body of the injector. What I want is 113 volts. Minimum is 110. You'll start experiencing problems any less. I have 113 volts. Very good. I test the other pin. .9. That's great. Now for the second test, I'll do the resistance. This will measure the resistance from pole to pole of the solenoid, and the spec for this injector is 0.215 to 0.295. And I just go pole to pole. Solenoid is good. And I'll do the same for all the rest. That's all in spec.
All right, so we've performed the solenoid test on all 4 injectors. Everything tested out just fine. This is a fairly basic electromagnetic solenoid, right? So voltage is applied here, turns this into a magnet, lifts some components in the injector, fuel fires through it. We want to make sure that the solenoid is good before we chuck this in the machine. We don't want anything shorted here. We don't want to damage our equipment. So you watch Brandon test this thing for resistance across the windings, post to post, and then you watched him test it for insulation, post to body. Make sure voltage is not leaking through the windings into the body. Everything tested fine there. We're going to go to the 205 and see what's going on with these injectors. All right, the first thing we have to do when we're in a test and advise situation is ensure that we have the capability to run the injector. So Mike gave us the part number for these injectors. We looked in our Bosch equipment. We do have factory supplied test specifications for these injectors. What we didn't have was the fixture needed to chuck the injector into the test stand. Now, this doesn't look like much, but ask Bosch for a price of this component and you will be surprised. We are fortunate to have a very modern and capable machine shop who can design and manufacture these components as we encounter them and as we need them. What goes into making this. We had the profile for the OD of this fixture because the machines are the same. They don't ever change that. What does change is the ID of this fixture because these injectors are unique. It's not one we've ran before, so no big deal for us. If we don't have it, we'll make it. So these injectors are going to go over to the 205. This is our benchtop tester for injectors that have been out in the field. So these injectors have some miles or hours on them. They've had lots of fuel run through them. We don't know the condition of the internals. We do not want to chuck these up in the final production machines and run the risk of introducing contamination or debris or some type of foreign particles into these machines. The 205 is a benchtop machine. It's intended for testing injectors that have been out in the field.
All right, guys, we had all of our solenoids pass, and I've actually ran the first injector in here, and it did very well. So I'm going to pull it out, and I'm going to put another one in, the second one in. This is our EPS 205 test bench. This is where we test our customer injectors. So I'm going to pull this one out of here. Remove our sleeve from the injector, and this sleeve we had to have specially made. So I'm going to move this injector over there on the cart, and I'm going to go ahead and grab the second injector. Okay, this is our second injector, and how I know that is when they come in, the customer normally numbers them in a specific bag or in a box. They want to go back in the same cylinder, so I engrave each one. Even if they got paint marker, sometimes our paint marker comes off as we clean them. So I lightly engrave each injector on the holder so we for sure know that this is injector number 2. When we got these injectors in, we did not have a sleeve that would fit. So our machine shop made these sleeves specifically for this injector. So make sure I got my O-ring on there, and we have an O-ring down in the sleeve, and I'm going to put this injector in the sleeve with the fuel inlet facing the right way. Okay. Put my fuel inlet in. Tighten her down. Now we make sure this is backed off so it gets a tight seal. Line this up. Snug our injector up. I'm going to tighten that down. So our fuel inlet's all ready, and now I need to hook up the return line. Pretty simple. And I hook up our solenoid connections now. The polarity on these does not matter. I am not going to hook up the fuel injection chamber yet because our first test the machine runs is a leak test. We want to see if the nozzle's sealing. Make sure it's not just continuously spraying. So I'm going to dry it all down, so if there are any leaks, we'll for sure see what's going on. Dry the nozzle. Okay. So I'm going to go ahead and start the first leak test here. I got injector number 2. We got our part number for our test plan. And it's telling you there it's going to be the first leak test. It runs 6 total steps. It has to be at a certain temperature, the calibration fluid, and you'll see as I start the test, it will raise our pressure and we'll check for leaks. You can see the pressure will stay in the red until it gets to where as high as it needs to be for this test. We're already getting some return, but that's good. The return spec on this is 0, and the spec is allowed to go all the way to 60. I don't have anything leaking yet. That's good. If there was a crack in the holder, if the nozzle was leaking, we would see it now. If it had high return, if there was internal damage to the injector. And it would be spraying. It would definitely be leaking if there was something wrong. Test. The return looks great. It's on very low. When it's finished, it's going to have me put our injection chamber back on. And it's dry. pressure on. Secure it with that. Our leak test is a go. I'm going to click on the green. Mountain injection chamber on test specimen. Start test. Okay. It's going to run a series of tests. The first test, TP2, the minimum delivery it can have is 107.6. The highest it can have is 131.4. TP2 is full load, so it's nearing the end of the TP2 test, and then it's going to measure how much return the injector is creating under a full load, and you'll hear it switch over. The return amount can be as low as 5 up to 70, but that high is not usually good. Switched over to measure the return. The factory spec for this at full load delivery is 119.5, and it got 122.92, so I believe that is running really good so far. Injector's definitely getting warmer now. That noise you hear is the fan cooling the calibration fluid in the machine. The last step, TP7, and this step, TP4, is just a fuel curve, different pressures. And the next step, BE, that's going to be your armature lift, how much that little bitty ball and seat is allowed to move. I know the first injector was on the high side of this, but it was within spec. Jump around until it evens out. injector is going to possibly fail VE. The ball and seat may be worn sitting on top of the valve, and it did fail for VE. Too high delivery. Our test. Here it will show you injector number 1 had all passed. This is injector number 2, and it gives you where it has failed for the VE test. I got 2 more to test, so I'm going to return out of this and add further tests. And now I will be ready for injector number 3. Just in case something does happen, I always leave the mouse over stop. I've seen them where they're cracked, where we got our number, and it won't even start spraying out until it gets up to the certain, like it'll pass all the way up to 100. Once it gets to 160, it's like this itty bitty stream just spraying. But these all seem to be passing. Leak testing. I don't know what makes them crack there. No, but as far as return goes, these all did really good. I mean, they're even on the, that's pretty low for as many hours. Because technically, it's in spec even if it goes to 60. So they're doing pretty good. They're on the low side. But if it was something like high 30s or 40s, I'd probably say something is getting ready to go bad. injector was running 33 at that return, so I mean, that's not too bad. The middle spec for that's 37. So the first one passed good, and then the last three failed for the same spec, BE.
All right, test complete. So what did we find? Of the 4 injectors, 3 of them technically failed the test plan. Now they failed the test plan for pilot injection. So one thing we should probably make note of, these injectors fire multiple times for every combustion event. So the piston comes up on compression, this injector fires 5 times for every combustion event. It's not just a single injection of fuel. It's got 2 pilot injections, small fuel deliveries to get the fire going, and then it's got a main injection, which is where you get the majority of your fuel, and then it can have 1 or 2 post injections where it finishes the burn and tries to optimize the combustion event for a variety of reasons. Noise, power, emissions being the primary functions. So a single injection of fuel would be a clattery old diesel engine. Modern common rail diesels are much more elaborate in their fuel delivery. A couple of small injections get the fire going. Once it's lit, give it all the fuel, make the power, make the fuel delivery, and then a couple additional injections to ensure a complete and thorough burn. 3 of these injectors failed on pilot delivery. So that initial small injection was too high on 3 out of the 4 injectors. Given the circumstances and the complaint from the customer, I don't think that's causing his issue. He has an intermittent low fuel rail pressure code. We would generally find that to be on the return side of the injector. So when we were watching Brandon do the test, first test was leak. And the only thing that machine does is apply 160 megapascals, so about 23,000 psi of fuel injection pressure is fed to the injector. There's no solenoid actuation. We're just charging it with fuel pressure, and we're checking it for leaks. We suspected we would have found a return issue or a leakage issue at that point, and we did not. So given the circumstances with the problem being intermittent and the injector not having necessarily shown the issue that would cause the code and symptom, we're now at a point where we have to determine what do we do for the customer. So there can be a lot to be considered here. Availability, pricing, downtime, frustration, lots of things go into this. The customer had to remove these injectors, and I'm sure they spent a fair amount of time doing that. They have about 3,000 hours on them already, which is about lifespan for this type of component. So they've got them out, we've got them in our hands. We don't think they are the culprit, but given the circumstances, the solution here is replace with a brand new Bosch injector. Now why is that? Generally, we would rebuild these injectors and return them to the customer. We have the solenoid in stock, we have the control valve in stock, we do not have the nozzle in stock, and the manufacturer is quoting an 8-week delivery on the nozzle itself. So all things considered, we can't rebuild them. We really don't want to return them as is, and they spent the time to get them out. They want this machine correct. We're going to send them a new set of Bosch, put this thing back on the road. So along with that, we're going to send a new set of push tubes. These are one-time use. So when you remove your injectors, these tubes need to be new when you go back together. But for sake of curiosity, we are going to go into these and see what we find. So this is the number 3 injector. It failed by the most significant amount out of the 3 that did fail. VE, or pilot injection specification, is 2.1 plus or minus 1.8. So maximum VE delivery specification 3.9. Number 3 injector measured 5.64. So we're going to have Brandon scatter this, and we're going to take a look inside and see if we can determine what the issue is. Now keep in mind, this injector has about 3,000 hours on it, and these specifications are aimed at production, so remanufacturing. These are for new injectors. This is not a brand new injector. So it's not uncommon for some of these specifications to be at or just outside of the test plan. But that doesn't mean, real world scenario, from the seat of the machine, that you're going to necessarily have an issue. Let's take a look.
Alright guys, I'm going to start. I'm going to remove this clip here. And then I'm going to remove the set screw, and there will be a ball under the solenoid. Now I'm going to go ahead and loosen the solenoid nut. Normally I would note which position the solenoid is if we were to rebuild this. Remove our nut. I'm going to take it out of the stand. And I'll try to take it apart as carefully as possible so you can see how it's put together. So our nut's removed. I'm going to give it a twist as it comes out. And our little bitty ball and shims sometimes follow it, and it did. So we got our valve and our set screw down in there. So here is our compression spring, our ball in our seat, our overlift shim, our armature plate and bolt, and inside here should be our valve spring and a VFK shim. Okay, we should have an armature lift shim. And now I can go ahead and break our internal screw nut loose. Put it back in our stand. Now we break this internal screw nut loose here. They're usually torqued around 50 Newton meters. That one was more like 100. Spin it out of there. Now I'll take this screw out of here and I'm done on this side. And that exposes our valve. So now I'll take out the nozzle and we can beat our valve out this way. So for this, I'm going to compress the nozzle down tightly, so as I loosen the nozzle nut, there's pins. You don't want anything to turn and snap or break. Just relieve any tension off the nut as much as I can. So this will push down, and go ahead and break this nut loose. Even with our precaution, it may have snapped the nuts. Nope, it was just really corroded. Carboned. Okay. Okay, should be able to get that by hand now. Okay, I'm going to go ahead and remove it out of the stand. And I'll turn this like that. Let me keep these pieces in order. Go ahead and remove our nozzle nut. Here's our nozzle, the pintle. Here's these pins I was talking of that align the nozzle, 2 of them. Now there's a very, very small, what I call the pill, and this adjusts fuel delivery at full load. We remove our guide bushing, and there's going to be a nozzle spring, and there's a shim under there called the DFK shim. Okay, I just take this here and beat this valve down and out, and we'll have to check the valve out under the microscope. The part set came with the valve, which is a good thing. So that's completely disassembled. We'll check this out under the microscope along with our ball and seat, and that is fully disassembled. It looks pretty good.
Alright, so torn down, and we're going to talk just a little bit of functionality here from 10,000 feet. So we talked earlier, this is a electromagnetic device, right? Electromagnetic solenoid. So when the computer commands the injector to deliver fuel, it energizes this solenoid, creates a magnetic field. The magnetic field operates on these components here, namely this armature, and it lifts it up into the body of the solenoid. Underneath that, and it's hard to see and it's hard to grab, is this little bitty ball. And this ball sets right in the top of the control valve, and it's tiny. I mean, you can barely see it. So when the solenoid energizes, lifts the armature and some of these components, pulls that ball off of the seat in the top of the control valve. High pressure common rail fuel, again 25,000 psi, is being fed into the body of the injector. When the solenoid turns on, it lifts the ball and it allows some of that fuel pressure to bleed off. That creates a differential in pressure on both sides of this control valve, and it allows the valve to lift inside of the injector. When the valve lifts, the pintle in the nozzle can then lift and fuel can flow through the nozzle, delivering it to the combustion chamber. When that injection event is turned off, the computer turns off the solenoid, fuel pressure then closes all of those components, and fuel delivery ceases. Again, we're talking microseconds. One combustion event at 2,500 RPMs doesn't take very long. and this injector is opening and closing 5 times for every combustion event, and this injector has 3,000 hours on it. So somebody more inclined and better at math than me can run the calculations there, but this solenoid has opened this valve millions of times at this point. Common mode of failure is erosion between this ball and this seat on the control valve. The ball you can barely see with the naked eye, so we're going to chuck it up in the microscope and just look at the ball and the seat and see if we see erosion. At 3,000 hours, it's to be expected. Even perfect fuel for that length of time is going to cause some wear to these components. The adjustments and calibrations inside this injector are set in microns, so extremely tight tolerances, a little bit finicky to set up and build, and absolutely intolerant of contamination, low quality fuel, debris, dirt. You have to be absolutely sanitary when you're working on these, and that's why you see the shop style that we're in. That's why you see us wearing lab coats, and that's why you see us taking such great care to do this as cleanly and precisely as possible. Let's go over and take a look at this component and see if there's anything to be learned.
Okay guys, I'm going to take this microscope here and see what we can see, if we can see any erosion on top of this valve. Okay, I removed the ball from the valve, so center it in here and try to get me a good view of this valve. The valve doesn't look too terrible, but it looks to me like it's a little, the fine edge that it should have is just slightly worn away from all the hours that's been on it, all the fuel that's been through it. I'm going to put our ball on it and see how our ball looks. I'll let you guys have a look and see. The ball has very minor scratches in it, but we were expecting this.
Alright, so control valve, ball, and seat inspection reveals what we're going to call normal wear. So we don't see significant erosion from a contamination type situation. We do see wear in it, but at 3,000 hours, that is to be expected. That wear will throw off the adjustments and deliveries in the injector to some degree, roughly what we've measured on the test equipment. But again, we're not seeing a smoking gun failure here. So with the problem being intermittent and temperature related, there's a chance it's still in the injectors, but all indications are telling us that these injectors are fine. Now, again, given the circumstances, the length of time to remove the injectors, the amount of time on the injectors, the decision has been made to replace them. Generally, we would rebuild these. We would use brand new control valves, brand new nozzles. We would set this thing back up to delivering with new specifications. They'd go back to the customer for another cycle of life. Due to parts availability issues, that's not an option, at least in the near future. We've got to get this machine back to work, and the only way that we can do that and ensure ourselves that we've done it correctly is with a new set of Bosch injectors. That's the answer in this situation. The fee to run these injectors is $40 a piece. Full test of your Bosch injector on Bosch equipment by a Bosch authorized facility and technician, $40 a piece, ensuring your diagnosis is accurate or potentially saving you from making an investment in an expensive set of injectors. If the test reveals that your injectors have failed and you buy replacement injectors, or if you allow us to service your injectors, we waive half of the testing fee so that you now have $20 to test them, and you can buy, exchange, or new, or we can rebuild your injectors for you. The price to rebuild your injectors is going to vary. The cost of the subcomponents is different for each injector. The labor time to rebuild them is different. It's an estimate upon inspection situation. These new injectors from Bosch, authentic OEM, first fit, highest quality available injector, they're about $300 a copy. A lot of money. If you think that's a lot of money, call your Volvo dealer and ask them what they get for them. I think you'll be surprised. Push tubes, always replace them. These are about $40 a piece. So, all in, testing, brand new injectors, brand new push tubes, back out the door, we're under $1,500. All right, if you find yourself in need of any of these products or services, please reach out to us and let us know. If you mention that you learned of us through this collaborative effort with fellow YouTube creator Dirt Perfect, we'll cover the shipping in and out for your products, and we'll throw in a pair of mechanics gloves to sweeten the pot. All right, if you need to get a hold of us, you can log on to our website at areadieselservice.com. You can send us an email at parts@areadiesel.com. You can give us a phone call at 800-637-2658. That single phone number rings all three of our locations, where you'll have immediate access to a diesel engine expert. You can also chat instantly with an expert through our website by clicking on the button in the bottom right-hand corner of your screen. If you're not already watching, be sure to check out Dirt Perfect's channel, where you can see these injectors get removed and replaced and find out if this was the answer to the problem. We want to thank Brandon for shedding some light on this situation and sharing his expertise with us.
No, I was honored to take the injector apart and see what we could find. I think we narrowed it down. It's definitely not from contamination or anything out of the ordinary. It's just from average hourly use. It's like you said, it's at the end of its lifespan, and while they're out, you might as well get new ones.
All right, we want to thank Brandon for allowing us to come down here and bother him, watch what he does. He is an absolute master of his trade and craft. If you need common rail injector work or testing, this is your guy. Thanks for watching.